guys, you are welcome to Dssg Nation. So if this is your first time watching a video from Dssg Nation, do make sure to subscribe and hit the bell button so we can notify you whenever we update any video. So today we are going to be talking about the endocrine system. So pick your paper and your pen and let's start. Hi guys. Okay, so we said we are going to be talking about the endocrine system. Endocrine system. Now, the word endo means within, while the word crine means to secrete. So when you say endocrine, endo and crine, it means to secrete within. So what is now secreting? What is responsible for the secretion? We said system is the combination of organs, right? So we said system means combination of organs. Combination of organs. So if system is the combination of organs, what are the organs in the endocrine system? They are glands. So they are glands. So they are those ones that secrete within. So, like endocrine system is just a combination of glands that secretes within. So what do they secrete? What they secrete is hormones. So, with this established, let's now try to correlate this system, or let's try to compare it with a worldly affair. So I'm going to clean the board and I'm going to come in with that. Stay tuned. Yeah, welcome back. So I said we are going to be comparing the endocrine system with just a normal day-to-day activities in our life. And what is that? That is just like a post office. So the endocrine system is just like a post office. So let's say this is the post office now. We know that the post office, their major work is to receive letters sent from distant places. So they are going to receive the letter. So we have a lot of letters now here, a lot of letters in the post office. So then the post office is going to send the postman, or as much as possible. And the postman will be the person responsible for distributing all these letters. So the postman is going to go to individuals' houses. So let's say this is a house. So we have their compound. So this is another house now. So we have their compound right here. So let's say here is their gate. So lastly, another compound. So this is the post office responsible for giving the letters to what? To this postman. So this is the postman, the man that used to distribute letters to I and you. So the person is going to move along the road, so through a road path. So he's going to move to people's house and is going to disseminate the letters to them. He's going to give them the letter. So if the person is not around, the postman can choose to keep it by the gate. So if the person is around, the postman can enter into the house and drop it for people inside. But if there is no one in the compound at that time, the postman can choose to just put it in the house. Or if the people living in those compounds are within their houses, so the postman can just go into the house and give them the letter. So same thing to this place. And this is just an example or a comparison of endocrine system with our day-to-day activities. So you're asking me what is the correlation, right? Just stay tuned. Now, this post office now is the gland. The post office is the gland. And then it sends the what? The postman. And the postman is what now? The messenger. So, but in our own body, in endocrine system, what is the messenger? The messenger is hormone. So the postman is the hormone. So the gland is the post office, the postman is the hormone, and the postman is going to move to each individual's house using the road. But within our body system, what is the road? It is not the road. In our body system, it is the blood. So and then the blood is going to take the postman, the hormone now, to different houses. So it's going to take people, it's going to take the message, the hormone is going to take the message to what? Different houses. But now it is not house. In endocrine system, they are called target cells, or you can call them target organs, or you can call them target tissues. So either of the three, and that is just the what? The correlation. So like the post office is the what? Is the gland, while the messenger is the what? The hormone. So the road is the blood, and then these houses, they are the what? The target cells, target organs, or the target tissues. So now, simple definition of endocrine system, you can just say it is a system which comprises glands that secrete hormones into the bloodstream, and that hormone are directed to what? To the target organs. And that's just a simple definition of the endocrine system. So we have different kind of glands. We have the exocrine, we have the endocrine. But we are not going there today. Let's just talk strictly about endocrine system. So now, what are the types of hormones that we have? What are the what? The types of hormones. So stay tuned, let me explain the board and then we'll get straight into the hormones. Yeah, welcome back. So we said we are going to be talking about hormones now. So what are hormones? So with the pictorial illustration I used in the previous thing, I said the hormones, they are just like the chemical, the messenger, the postman. So hormones are just chemical messengers. So we have different messengers in our body and they are grouped into, I think, 4. So, but I don't want us to be talking about them now. We have the neurotransmitters, we have these hormones as well. So, but I don't want us to be talking about that now. Let's talk strictly rather on hormones. So in our body, these hormones, they are responsible for taking message to target cells. So we have majorly 2 types of hormones, but I just want to do this. Let's say hormones are classified. So classification of hormone using 2 criteria. So the first one is their chemical nature. So we have types of hormones based on their chemical nature, or classification of hormones based on their chemical nature. And then we have classification or types of hormone based on their solubility. Based on their solubility. Now, based on their chemical nature, what are the types of hormone? We have 3 types majorly, but in most of the textbooks we just find 2. It is correct 2, but I can't just start to explain the reason why it is 2 and 3 in some other textbooks. Maybe I'm going to make a video on that separately. So for now, just take it, we have 3. So the first one, this chemical nature is talking about where they are being produced. Like what they are made up of. So the chemical nature now, we have 3. We have the peptide hormones. So the second one, we call them the steroid hormones. And the last one, they are called derivatives of amino acid tyrosine. So these are the types of classification of hormones based on what? Based on their chemical nature. So what they are produced from. So these peptide hormones now, what are they? They are the hormone produced or formed from what? Peptide. And peptide is what? Your protein. So they are the hormone made from protein. So the steroid, so they are the hormone produced from fats. And lastly, the derivative of amino acid tyrosine, just as the name sounds, derivatives. That is, they are made from what? Amino acid tyrosine. And that is that and that. So now, let's clean this solubility for now. We are going to come in there later. Now, we have an example of peptide hormones. So one of those things that used to bring about confusion in the endocrine system It's trying to place your hormone, trying to classify it, like which ones are steroids, which ones are peptide. So just to do that, you can just follow this acronym I'm about to give to you. So under the peptide hormones, the acronym for the peptide hormone is just P raised to power 4. Although you can still have more than that. So what does P raised to power 4 mean? So the first P is the pituitary gland. So the second one, we have the pancreas. So the third P, you have the parathyroid hormone. So and the last P is the pituitary, the pancreas, it still remains one, but I think I've forgotten, but I'm still going to remember before the end of the video. So in short, what do I mean by examples of peptide hormones, P raised to power 4? All hormones secreted by the pituitary gland, they are peptide hormones. So and what are the examples of the hormones secreted by the pituitary gland? We have the growth hormone, we have the prolactin releasing hormone. So we also have what? Dyscrepsity. So adrenocorticotropic hormone, ACTH. Don't worry about abbreviations, I'm going to give you the full name as we move on in this video. So hormones secreted by the pituitary gland, in short, they are what? They are peptide hormones. So same thing with the pancreas. The pancreas is secreting insulin and glucagon. So insulin and glucagon, they are what somatostatin too. So they are what? They are peptide hormones. As simple as that. So the next one is the parathyroid. The parathyroid gland is secreting PTH, the parathormone. So the parathormone is a peptide hormone. So wait, let me try to remember this once again. The pituitary, the pancreas, the parathyroid, and placental hormone. Yeah, there are some placental hormones as well that are what? That are peptide hormones, although not all. So you can make research on that yourself, the placental hormones. So and that is that on what? On the peptide hormones. So for the steroid hormones, so what are the examples of steroid hormones? As simple as that. The steroid hormones too, the acronym is just GAP. The acronym is GAP. So this G is gonadotrophin. So all hormones under gonadotrophin. When you say gonadotrophin, the word gonad is talking about the sex organs. And in male, the sex organ is what? That is the testes majorly. And in female, it is the ovary. So the hormones of the ovary, the hormones of the testes, they are what? They are steroid hormones. So example are what? Estrogen, then progesterone as well. So and after that you have what? Testosterone. So all those hormones, they are what? They are steroid hormones. So this A is adrenal cortex. So all the hormones secreted by the adrenal cortex, they are what? They are steroid hormones. So I'm still going to be knowing more about it as we move on. Just stay tuned and make sure you click the subscribe button, so when we release description of each gland, you are going to be aware. So like adrenal cortex is secreting cortisol, and after that is for the what? That is for the zona fasciculata. So for the zona glomerular secretion, aldosterone. So making two. So aldosterone. Then after then cortisol. Yeah, cortisol. So those things, adrenal cortex, they secrete adrenal, they secrete aldosterone, cortisol, and the last layer, zona fasciculata, is secreting what? Is secreting the sex hormones, the androgens, so the estrogen and the like. So all those things, they are what? They are the steroid hormones. So the P is placental hormones, so there are some placental hormones that are still steroid. So I said you can make your research on that. So that is that on that. Now the last one, the derivatives of amino acid tyrosine. For the derivatives of amino acid tyrosine, we have the thyroid hormones. So and what are thyroid hormones? We have majorly two thyroid hormones. The first one is what? The T3, and the other one is the T4. So the T3 is the triiodothyronine, and the T4 is tetra. So tetraiodothyronine. It's also called thyroxine. So they are what? They are derivatives of amino acid tyrosine. So I believe with this classification based on the chemical nature, you should be able to group hormone. When they just ask you, progesterone belongs to which kind of hormone? You can just tell them, oh, progesterone, that's a gonad. So it means it's steroid hormone, because GAP is our acronym. So if you follow this, trust me, you won't make a mistake on that. So I'm going to clean the board, I'm going to call them with the solubility. Stay tuned. Yeah, welcome back. So we said we were talking about classification of hormone. So we said classification of hormone, you can use the chemical nature and you can use the solubility. So under the chemical nature, I said you have the peptide, the steroid, and the derivative of tyrosine. So tyrosine rather. So let's talk about classification of hormone based on its solubility now. Solubility. So we have usually two classifications. So we have the water soluble, and the second one is the fat soluble. So we have some hormones that are water soluble and we have some hormones that are fat soluble. So the water soluble hormone and the peptide hormone. While the fat soluble are the steroids. That is steroid hormones. Now, what is the significance of having classification of hormone based on the solubility? So we understand that the significance of the importance of classifying the hormone based on the chemical nature of the time is for us to know where they are produced from, right? So what is the significance of classifying hormone based on their solubility? Now, please stay cool and just stay calm, and then you are going to understand this. But if you rush it, trust me, you can mess up. Now, why are we classifying them based on water and fat, based on their solubility generally? Why? Now, I said the postman is going to go into what? Different houses, right? And we said this is the major house where the people in this house are living. Now, I said here is their gate, right? So, I said if the postman meets nobody at home, the postman can just keep it by the gate. They can have a kind of bottle, a kind of water bottle, most of the times, in Nigeria to be precise. So water bottle where you can just drop the letter. So let's say it means the letter can be received by the gate, even if there is nobody at home. That is one matter. Now, I said the postman can enter if there is a gate man, and if there is nobody at home, they can just put it anywhere within the compound. And I said there are some people at home, the postman can just enter and just drop the letter with someone, anybody that he or she meets in the house. Now, which means we have 3 sites for receiving the letters. So the first one is what? The first one is just by the gate. The second one in the compound, and then the last one is in the house where people are living. Now, everything I just explained here, they are called the site of receptors. Site of receptors. Site of what? Site of receptor. I'm going to explain more about it when I clear this word. But what I want you to know is that we realize that some letters are going to be dropped just outside the house. Let's say all this thing I'm drawing are gates. So some letters can be dropped outside and some can be dropped inside. That means we have 2 major receptor sites for letters. Receptor is something that receives. We are going to talk about it much in the next thing. That's why I say you have to stay calm right here. Now, based on hormones now, I said this postman is an hormone. Now, if hormone is coming to this house is the target cell like that. So which means hormone can bind with a receptor on the cell membrane, or it can go into the cell. That is just what I'm trying to emphasize. So, can you now see these water soluble hormones? These water soluble hormones, they are the hormones that bind with their receptor on the cell membrane. Or just say they bind their receptor outside the cell. So, example of peptide hormone is what? Your growth hormone, right? It means your growth hormone binds with their cell. Okay, binds with the cell membrane. So the receptor site is outside the cell. What's the meaning of receptor? I'm going to talk more about it when I clear the word. So now, for this fat soluble, they are able to cross, so they can enter through the gate. The gate man is going to open the door for them, so they can enter into the compound and then drop the letter inside the house. Which means the fat soluble, the steroid hormones, their receptor is what? Inside the cell. Inside what? Inside the cell. And that is the reason for classifying hormones based on their solubility. Just for us to know where are they going to bind to. Is it on the cell membrane outside the cell or inside the cell? That is the reason for doing what? For classifying them based on their solubility. I really can understand this. If you don't understand this, you can just always come back, just rewind and then watch it again. So now let's talk about the site of receptors. We said our endocrine system is comprised of the gland, the hormone, and the what, and the receptors. I mean the target cells rather. So let's talk about the target cell. That is what I'm going to talk about, receptor. So we talked about hormone, classified it into two, and we cited some examples and the acronym for remembering them. So now let's talk about the last one, which is the house that they are going to deliver the letter. Stay tuned. Yeah, welcome back. So we said we are going to talk about the last thing, the house. So I said if this is a post office, so you have the road, and then it's going to supply the letter to your house. So it can be dropped by the gate or inside the house. Now I said this post office is the gland, the road is the blood, and the postman is the hormone. The hormone. So this house now is the what? The target cell. Target what? Target cell. So we've talked about the hormones. So let's talk about the target cell now. So if this is the target cell now, so let's draw our cell proper. So look at this diagram of the cell. And after then inside it, we have the what? We have the nucleus, the centrally placed nucleus. I don't want to be giving the landmarks of the nucleus. Let's just leave it like that. So nucleus. So I'm going to use our cell membrane. Our cell membrane. And here we have our cytoplasm. Our cytoplasm. So cytoplasm. Cytoplasm. Now, if this postman that is the hormone is bringing the letter, the postman can drop it by the gate. So here on this cell membrane we have some things called receptors. Just from the word receipt. You know whenever you go to buy something they give you a receipt. So you receive the receipt. So there are some things on the outer part of the cell, that is on the cell membrane, that receives the hormone, the letters. So those things are called receptors. Receptors. So they are called receptors. So we have receptors on the cell membrane, thousands of receptors on just the cell membrane, according to Elimere and series. We have thousands of what? Thousands of receptors on the cell membrane. So we also have some receptors in the what? In the cytoplasm. And we also have some receptors in the nucleus. Now, we have a trouble now. And what is the trouble? How do we identify hormones that will bind with the cell membrane? How do we identify the hormones that will bind with the receptors in the cytoplasm? And how do we identify the hormones that's going to bind with what? That's going to bind with the receptors within the nucleus. But trust me, it is not the trouble. Let me just say that. Now remember, we said we have three types of hormones. I mean, based on their chemical nature. So I said the peptide hormone are the first one, and the acronym is P raised to power 4, and we talked about that. Although we are still going to lay more emphasis on that as a moment. Now, the peptide hormone under the solubility, I said they are the water soluble. So because they are water soluble, they are lipophobic. I really forget that, but let me just leave that for now. I'm still coming back. Now, the water soluble, I said they bind with what? Their receptors on the cell membrane. So, water soluble, the peptide hormones, they are the one that binds with what? They are the one that binds with the receptor on the cell membrane. So, I said the second one are the what? The second one are the steroid hormone. So, the steroid hormone, they enter into the cell membrane, just like a postman entering into the house. So, they enter into the cell membrane and then they are going to bind on the what? On the receptors in the cytoplasm. So, the cytoplasm now, the receptors they are meant for what? The steroid hormone. Steroid hormone. So the steroid hormone, your gonadotrophin producing hormone, your gonadotrophin rather, they bind with the what? The receptors in the cytoplasm. And the last one under the chemical nature is what? Derivatives of amino acid tyrosine. So the derivative of amino acid tyrosine, they bind with the receptors inside the nucleus. So derivatives of amino acid tyrosine. So tyrosine. They bind with what? They bind with the receptors inside the nucleus. And that is that on that. So a quick recap for this. The postman, which is the hormone in the endocrine system, is going to take closer to this house. So the postman can either rotate by the gates into the compound or into the very house. So the very house is the nucleus, and the compound is the cytoplasm, and the cell membrane is what? The compound. The gate rather. The gate. So like we have three receptor sites now. We have the receptor sites on the cell membrane, the receptor site in the cytoplasm, and the receptor site in the nucleus. So our classification of hormones based on chemical nature now, the chemical nature. We said we have the what? The peptide. So the peptide are going to bind with, let's call this one receptor site. Receptor site for this side. So our peptides, they are going to bind with the what? With the cell membrane. Receptors on the cell membrane. And classification of hormone based on chemical nature. The second one is what? Steroids. So as steroids, they are going to bind with what? They are going to bind with the receptors in the cytoplasm. And lastly, the last one is what? Derivative of amino acid tyrosine, derivative of amino acid tyrosine. Amino acid tyrosine. So they are going to bind with what now? The receptors inside the nucleus. And that is that on the receptor site. So the next thing we are going to is the mode of actions of the hormone. And after that, we call it a day for this video. So we are going to start with the pituitary gland in our next video. So let me click on this and talk about the mode of actions of the hormone. Stay tuned. Yeah, welcome back. So I said I was going to talk about the mode of actions of the hormone. Mode of action of hormones. So the mode of action is something that is very deep, but I'll just give us what is necessary. Now, if you want to talk about the mode of actions of the hormone, what I expected to talk about is the journey of the hormones, where it comes from. Should tell us about that, and then you should tell us the mode of transportation, the mode of what? The mode of transportation of that hormone, mode of transportation. So then you should talk about the target cell and its receptor, and its receptor, and its receptor, and then lastly, you should talk about the longevity of the hormone, Now, what's the meaning of all this? When you are talking about the mode of action of the hormone, so tell us where it is coming from, and that is what? Just say after a gland secretes an hormone. So the word gland, it means that is where the what? The hormone comes from. We've done justice to that. Now, the hormone is going to be secreted into the blood. That is your mode of transmission, mode of transportation rather. So the gland is going to secrete the hormone into what? Into the blood. So you've done justice to the mode of transportation like that. But let me ask you a question. Since the hormone is secreted into the blood, it means the hormone is going to circulate to nearly all the body parts, because the blood is the only thing that connects the majority of the body parts together. So it means the hormone is going to circulate throughout the body system before it finds its target cell or target tissue or target organ. So always put that in your mind, and you can always put that in your mode of transportation rather. Just say after the hormone is secreted into the blood, it travels throughout the body and the body tissues. So now what happens next? It's going to identify its what? Its cell, and that is the what? the target cell, the destination. I hope you are getting what I'm explaining here. So now, when you talk about the target cell now, we are going to tell us the receptor. Then we are now going to say if the hormone is a peptide, it is going to bind with the receptor on the cell membrane. And then if the hormone is a steroid hormone, it's going to bind with the receptor in the cytoplasm. And if the hormone is a derivative of tyrosine rather, it's going to bind with receptors in the nucleus. And we've done justice to what? To the receptor site. So a quick recap. When you are asked to write a mode of action of hormone, 5 marks, you start by saying the hormone is secreted by the gland. You can choose to put a gland like example, you can just click some glands. So and then it is secreted into the blood, that is your mode of transportation, and tell them that it's going to travel throughout the body before finding into the cells or direct tissue. So then what happens next? You say it is going to bind with the receptor depending on the type of hormone that it is. So if it's a peptide hormone, it binds with the receptor site on the cell membrane. If it's a steroid, within cytoplasm, and if it is a derivative of tyrosine, it's going to bind with the receptor in the nucleus, and that is that and that. But before I leave that side, I was talking about lipophilic and lipophobic the other time. The protein-based hormone, the peptides are lipophobic. What is the meaning of lipophobic? The word lip is talking about fats, and phobic means hating of hearing. So, because it is lipophobic, it is unable to cross the cell membrane. Because anything that wants to cross the cell membrane must be lipophilic. And we are going to talk about that in blood-brain barrier. Yeah, the blood-brain barrier. So, we are still coming back to that place. So, now, we are still here. So, the peptide hormone, they are called lipophobic hormones. Why? Because they can't cross the cell membrane. Anything that wants to cross the cell membrane must be fat. Although not everything. We are still coming to the blood-brain barrier. I'm still going to explain that. If this is confusing you, just leave it. So, the next one, the steroid hormone. The steroid hormone are lipophilic. And that means what? They'll be able to cross into the cell membrane. So that is the reason why they can cross into the what? Through the cell membrane into the cell to bind with the cytoplasm or the nucleus. I really hope you get that. So that is that on the receptor side. Now to the longevity of the hormone in the body system. This is just it. The hormones, they work like the thermostat in your house. So when the heat is too high, it drops itself. So the longevity of hormone in the blood depends on its mechanism. So from our mechanism, we know that we have 2 types of mechanism, right from our homeostasis rather. So we have the positive feedback mechanism and we have the negative feedback mechanism. If you don't know this, just go and watch our video on homeostasis, you are going to understand it. So the longevity of hormone in the blood is determined by the kind of mechanism it is. So naturally, if the level of hormones is really high, it is going to drop by itself. Because the cell secreting it will signal to the brain that this is enough, it's too high. Then it is going to drop by itself. So, and if the hormone is low, the cell is going to tell the system that the brain that it needs that very hormone, and that is going to lead to the secretion. So let me not be like this. For the longevity, it depends on whether it's a positive mechanism or a negative mechanism. So if it is a positive feedback mechanism, the hormone is going to stay longer in the blood. When it is the negative feedback, the hormone won't stay really long. It won't stay for long in the blood. And that is just that. On that. So when we start discussing the pituitary gland, we get more understanding of this feedback and how they work. So I think we are done for today in this video. So if you really enjoyed this video, make sure you give it a thumbs up and a like. And if this is your first time watching a video from Dssg Nation, just do make sure you subscribe and hit the bell button so we can always notify you when we create any video. So if this is not your first time, I also think that the only way you can help us is by sharing this video to your loved ones. And that will really go a long way with us.